I think there's some confusion differentiating between what a class and an object is. But an object is simply an instance of a class. So here's a couple of objects you've used before: the string and the scanner. So I have a string hello equals hello world, and a scanner equals a new scanner, and I read from system input. These variables, this first one, variable hello, is an instance of the string class, and the second variable, scanner, sc, is an instance of the scanner class. These are objects. So as it turns out, you've already been using objects this whole time, and anything that is not a primitive type, like int, float, boolean, whatnot, is actually an object. So here's how to design a class. A class serves as a template for its instances. It's the template for which you use to create the objects of that class. So how would you create a generic class that could represent a bank account? Well, here's an idea. All bank accounts have a balance and an account holder, so each newly created instance of a bank account should have those attributes. And here's another idea. All bank accounts should have withdraw and deposit behaviors that all work in the same way. So we need a way of updating the balance when a withdrawal or deposit occurs to any bank account. So here's a better idea. All bank accounts share a withdraw method and a deposit method. So they all do the same thing, but control or access to the balance of a bank account is strictly restricted by using the withdraw and deposit methods. So let's look at a demo. Here in a class I call bankaccount.java, this will be the template to create bank account objects. So we need two things. We need something to represent the holder, and then something to represent the balance. Okay. So variables that you declare in this global scope of the class are sometimes called member variables because they're members of the bank account and they're the attributes accessible throughout the entire class that represent your object. So in this file I call testbanking.java, I create a new bank account object with this new keyword. I call it account1, and then to access a class's members, I use this dot notation. So the object dot the attribute that I want to see, and I print it out like this. So I create a new bank account here, but in this example, I don't set any of these values. So we can test this to see what it prints. And here we see the name was instantiated to null and the balance was instantiated to 0. And that's because when you create a string without setting it to anything, it's set to null. But these variables, when you create an object, get initialized to whatever you set them up here. So if I update this to 100, we'll see here when I run it, now the initial balance is 100. So now that we have the attributes set up, we can go about updating them. So say I wanted to update the holder name, you can use this dot notation again, account1.holder, and you just set it to the new name. So we can test this out where I update one of the attributes. So we see initial name is null, but then the new name is Evan. Now lastly, we want to implement the withdraw and deposit behavior. So we need two methods. We'll call this one, we'll do withdraw first. or what example would I use here first? Let's do deposit first. So deposit, you're just depositing money, so it shouldn't return anything. So we'll have it return void. And then we want to deposit a certain amount. And this is different from the methods you've written before because there's no static keyword here. And all that, well, it's a complex explanation, but when a method doesn't have the static keyword, that means the method is called on the object, an instance of the object rather than on the class itself. So I'll show you what that looks like. But here, so when we want to deposit an amount, we say we want to update this balance. We want to increase that by this amount. So say balance equals plus equals amount. And once we're in this method, because the balance was declared outside here, globally inside the class, we can access it within this method here. And then we want to do the same thing for withdraw, except when we withdraw, we deduct. So here is how you call a non-static method. You call it on an instance of the class. So we call it on account 1. And then we do the same thing with withdraw, and we'll print the balance before the deposit or after the deposit, and then the balance after the withdrawal. Okay, so our name initially is null, our initial balance is 100, our new name is Evan, our balance after the deposit, after depositing $100, yep, is 200, and balance after withdrawing 50 is 150. So in here, we created the attributes to represent a bank account, and then we created a couple methods to be able to control access to this balance via deposit and withdraw.